Hello and welcome to LuckyMath. This is going to be a short video on the natural logarithm, and for this I want to quickly repeat what we've learned in my earlier video up there. So suppose we have an exponential function a to the power x, where the base a can be any real value that is positive and not equal to 1, and the argument x can be any real value. Then there exists an inverse function to the exponential function, which is the logarithm, and so the log to this same base a will take us back exactly to the argument x. And also, if you have the log to a base a of the argument y, where in this case the base a of the log has the same restrictions as when you consider the exponential functions, but now the argument in the log y has the restriction that it has to be positive, because the logarithm can only take positive arguments. Then there exists an inverse function 2, which is the exponential function, and so you take the log to the base a in the exponent of a, and it takes you back to the argument y. Let's do a quick example. Suppose the base a was 3. Then we have the exponential function a 3 to the power x. And the inverse function of 3 to the power x would obviously be log to base 3, and this takes you back to the argument x. And also, if we have the log to base 3 of the argument y, it would be the exponential function 3 to the power x. So 3 to the log 3 of y takes you back to the argument y. Alright, now I hope that you noticed that the base a can not only be an integer value, as for example 3, but it can also be an irrational number, because a is only restricted to positive real values and it shouldn't be 1. But then it can also be, for example, e. So e is the Euler number, it is an irrational number, and it is approximately 2.71828, and so on. And then what you would get is the exponential function, the natural exponential function, e to the power x. And I have a separate video on this function up here, and the very special thing about this function is that its derivative is equal to the original function. So e to the power x, the derivative is again e to the power x. And this is very useful, and therefore we call this function the natural exponential function. And the inverse function to this function is obviously the log to this same base e. That takes you back to x. But now we can also write ln of e to the power x. And this is exactly the same. So ln is simply an abbreviation for the natural logarithm. So this is the same as log to base e. But we use this function so often that it's easier to always say ln than log to base e. That's basically it. And also, if we already have the log to base e of y, then it would be the exponential function e to the power x. That is the inverse function, it takes you back to y. And obviously we can rewrite this also as e to the power ln of y, because ln is the same as log to base e. And this equation right here is going to be very important as soon as we start and try to take derivatives of exponential functions, for example 2 to the power x. But I'm going to do a separate video, and as soon as this exists you will find it up here. Alright, now, so what we've learned is that the natural logarithm ln is a function that takes positive arguments, as all logarithms do. It maps it to all values on the y-axis, so to all real values. So it takes an argument x and maps it to the natural logarithm of x, and this is just equal to the log to base e of x. And in the next video I'm going to show you how the graph of the natural logarithm looks like, and anyway as the graphs of all logarithms looks like. So thanks for watching, rate the video, subscribe, and see you soon again on Lucky Math!